So,
Yeah, it's very good.
how many of you know Avi? Just to have an idea of, okay, you, and probably you, yeah. Okay, cool. So, the idea of these is giving a bit of an introduction of what Avi gives and what is the difference, main difference between Avi and the rest of the other products that do load balancing and other things. So, Avi is what you're going to be slowly replacing the NSX load balancers and many of the load balancing capabilities on the VMware product. So the idea is it will be a load balancing, a WAF, anything related to application delivery on the VMware products, and it's going to be slowly integrated into that. And what we are seeing is I started playing around with Avi on the professional services side for the last 4 or 3 years, and it came from no one wanted, and now slowly every single project that we have, sooner or later, will have a component of this solution. So what I'm going to do is literally going through the basics of the differences, what it can do, what it cannot do. I'm trying to make a bit of parallelism of what we know about load balancing a bit. Okay, so.
Sorry, but I was going to shut the door.
Yeah.
Just hear the lady chatting outside.
So these 4 topics about it. So one is pretty much who I am, why do you want to listen to me, and what I'm doing in VMware. And then the other topic is slowly going through the one-to-one basis. So don't expect to know a lot about what the ins and outs of the solution is, but it gives you an idea of what is the difference. And then use cases. When I say use cases are normally everyone looks at a load balancer and assumes, oh, this is going to be load balancing. Now it does a bit more than that. And then there is 2 real implementations that if we have time, I can go through implementations that we did in customers. Some of them, of course, I think the majority of the information is anonymized because it is massive customers, so it's not 1 or 2, and there is a lot of sensitive data on it. But okay, so where am I am Ricardo Adao. I work in VMware probably for the last now 4 years and something. From yesterday, probably Broadcom, VMware, something like that. So before that, I was in Rackspace, which is a service provider across the globe. And before that, I was working in Portugal for majority of the networking business, as in from small Cisco's to big Junipers or big whatever you can imagine. I worked in majority of the service providers. So from cable to fibers, anything. When I moved to VMware, I focus mainly in NSX. Then Avi was acquired, and I start slowly working with Avi and NSX. And nowadays, a lot of the UK projects related to Avi that goes through the PS have some sort of my interaction in the worst case scenario to scope out and help out deciding what is going to be the best resource. But a lot of them is going to be either implemented by me or by someone on our team that works, and I do the architecture with them. So I am Portuguese. I brand board in Lisbon. So pictures from Lisbon. So pastéis de nata for people that know a bit more about food. Under food waves. So for the last couple of years, we know that in Portugal there's like massive waves that happen a couple of months a year, and they have all the XXL competitions there, and it's been quite funny about it. This is a picture from my hometown, so Lisbon. So there is a castle on the top of the hill. I think it's whoever visit Lisbon that has an idea that, well, we can cycle everywhere. Good luck with that. It's in the middle of 7 hills. It does not have flat surfaces, so you either go uphill or downhill all the time. In this map, there is a couple of regional foods, and if you look in deeper, there is no chicken there, so Nando's is not Portuguese. It's a joke that I do. It's a shame that Bilal is not here because I know that he's a Nando's fanatic, but Nando's is the South African and Mozambican. Peri-peri chicken is definitely not our traditional food. We have a lot of different foods. It goes from vegetarian to full meaty, whatever you can imagine. So if you like food, Portugal is a good place because you are not stuck with pasta all the time. You can eat pretty much everything. Things that I like to do, so anything related with the engine, I'm fine with it. I don't mind even to run. If it was a lawnmower race, I'm going to do it. Sports, so I'm a big fan of sporting, which is Cristiano Ronaldo whole team, and it's pretty much the only football that I see nowadays. And then NFL, Green Bay Packers is my team for the last 10 years. Surfing, gymnastics is pretty much I keep active, so every time I go to Portugal, I spend a lot of time in the water, or everywhere that I can go that I can surf, I surf. I did gymnastics for 30 years before I moved to UK, so it's what some of my passions is all about sports, being honest. Then my kid, he's 4, he's becoming a little, I would say, a little challenge nowadays, but he's growing and he's being like a really good addition to the family. Okay, so we're gonna go through a quick overview of what is all this AVI stuff is, or I'm gonna use AVI, NSX Advanced Load Balancer. I think that we all end up using AVI because it's way easier to say. But the idea is, everyone think, just another load balancer product. Is it? So, one of the big difference from all the other ones is a pure software-based product. You actually don't have a chassis that you can buy like an F5. It's not only it's only the software piece that is part of the AVI product. It can be completely API driven, and this is an important big difference from all the other products. Is almost, we have customers that rarely touch the UI at all, or the UI is purely used for the application owners to see the statistics. They can't figure anything through the API or through the UI. There is a lot of features that I expose on the API that are not on the UI because the main focus of the product is to be automated. So there is a lot of features that start from the API side and then slowly we get into the UI. There is a lot of pre-built integrations that you can use with multiple cloud providers. So you can connect these to use, for example, your own controllers to create service or load balancers on AVI on AWS, Google Cloud. Majority of the basic hyperscalers can use it. That is all baked in, so you don't need to create that integration. It's almost creating the authentication piece, and that is done. The analytics and reporting is normally one thing that is kind of overlooked majority of the times, because, for example, if you look at other products like F5, you go to the UI, and the analytics are typically related to the networking basic stuff. So it does not give you any information about, for example, your service, your HTTP request, or what is happening there. On the analytics and reporting part of AVI, you actually can see more that it can be helpful for the application team. So, for example, troubleshooting some problems with the service on the web on a layer 7 basis, you can see what is going on a payload, you can see the errors that are being introduced by the multiple stages of the interaction. So you can see what the web service is responding, where it's going to lose time, how long it's going to take to process the request. You can actually see a granular items of what is happening. And then there is the dynamic autoscaling, which is pretty much one of the key things on AVI, which is if you have a traditional load balancer, you have a model of active standby majority of the times. You have a chassis or a VM appliance that is running, and the other one is there, sitting there for whenever one fails, right? In AVI, you have a way of making sure that all the VMs, all the chassis that you use, they are all doing work. As in, your service can be running in multiple machines at the same time or in multiple instances without you having one that is just sitting there until the other one fails. So you increase the redundancy and the capacity overall by scaling horizontally on top of scaling vertically if you want. So instead of buying a bigger chassis, you can build a smaller chassis, 10 small chassis. And when I say chassis, in this case, we are talking about majority of times of VMs. We are not talking about putting a physical server on the data center running something. You are actually running everything majority of the times in VMs. AVI is a distributed architecture similar to NSX the way it works. So you have the management plane and the data plane, and then the control plane. You have the same sort of topology. You have the ALB controllers that deal with configuration, statistics, everything that you want to manage the solution. and then you have the data plane, which is the service engines. The service engines are where your load balancing runs. If you do a parallelism with the NSXT, it's pretty much the controllers are like the managers, the service engines are like the edges. So it's where your data, your customer data goes through. It's nothing besides statistics and logs on the controllers. If you lose a controller, only if you start rebooting in panic, everything else, you're going to start losing the user traffic. So it means that, for example, for upgrade, you can upgrade the controllers, and then when the window that you define, you can push the upgrade for the service engines in a staged approach or in a phased approach. You don't need to create a disruption out of nowhere. You can control that disruption. These can be run in bare metal machines, so it can run directly on the hardware, it can run in VMs, it can run in containers. The solution for containers is slightly different. It's not the same thing as a container running inside the Kubernetes context. It's a bit different, but it can be automated to a point that you run or you create a service for an ingress, and then everything is configured through the API or the controllers without you needing to go to the UI. So there is a component that runs on the Kubernetes side that controls all that automation for you just by you asking, I need an ingress service. It does run on premises, so it can run on your VMware installation on your data center, or it can run in majority of the public clouds with hyperscalers. That counts VMCs, AWS, Google Cloud, everything. The big topics are, you have a central point of orchestration, so your controllers is where you deal with everything. You rarely touch the configuration of the service engines, or you rarely connect to a service engine except for troubleshooting specific issues. But majority of the logging that you receive in the controllers is more than enough to troubleshoot the basic problems. So only when you go through a lot of interactions that you cannot actually understand what is happening is when you log into the service engine and you start looking at, let's say, connectivity issues between your service engine and the applications, something that you actually need to go, but rarely you need to do that. Elasticity. So when you grow, when you need more performance or when you need more throughput, you can grow your service engines by adding more service engines. You are not stuck with one single chassis. Depending how you configure your service engines, it does allow you to start with 2 for redundancy and then grow to up to whatever you imagine until you basically get to a point where you need to create another set of service engines. The resilience in the solution is on the numbers. So the fact that you can have more than one, always, in the worst case scenario you can have an active standby, you always have a guarantee that when you lose something, you have something that's going to work. So it is more, when you increase the number of service engines that you provide service for you are also reducing the impact of a failure. Because if you have 10 service engines and then you lose one, you are losing 1/10 of the capacity. When you have an active standby, you lose one, you lost 100% of the capacity, and then you have 100% on the remaining one. Automation, so all of these, believe it or not, can be automated in multiple factions. So the API is REST API, it can be all driven by API. You can build an entire solution with your own automation piece. So one of the use cases, or one of the situations that I have down is a customer that decides to do the no orchestration, so the read-only mode, which is you deploy your service engines, you deal with the connectivity between the controls and service engines. You don't need the controller to deploy the service engines for you. But you can automate that. So what they've done is they automated it in a manner that every time they need to do a change, they pull the configuration from their GitHub, they change something, they push the configuration from their GitHub, and then they have a process that kind of push the configuration to the controllers, and the infrastructure changes based on what they need. And they do that probably in weekly basis majority of the times because the way their business works, they need to shift the capacity across multiple workloads. And then you have the analytics and observability, which is the part that is a lot useful. It's more useful for the application owners and for troubleshooting than people sometimes imagine. For example, on the other day, I had a customer that they migrated the service for their new AV infrastructure, and the final customer, so he was complaining that their service stopped working. And it stopped working because they were getting a forbidden 403 when they were doing the request for service. And they were saying that it was the move that broke it. And they were adamant that it was the load balancer problem. But when we got to the load balance analytics and the logs, we were seeing that the request was going through the load balancer, it was getting to the backend server, then when it came back from the backend server, it was at 403. So it was the active web server that was saying that you are forbidden to make a request. When we drill in the configuration of the Nginx in that case, it was a reverse proxy configuration that was stopping our new IP from the load balancer to get to the backend server. So if we didn't have these logs clear there, it would be really hard to explain to them that, look, your problem is here. And that is really helpful for troubleshooting in a quick manner, or to basically do that first triage of, instead of start digging, let's make sure that we know where the problem is. If it is a latency problem, and you have a layer 7 load balancer, for example, you have the option, you have the understanding of where you are losing time. You basically have how much is taking your request to get to the load balancer to the backend server, how much time the backend server is taking to process your request and then reply back. So you have that in a visual manner that is really, really easy to understand. So I see, for example, some customers give access, read-only access to the application owners to see all these statistics because it helps them also optimize their applications. Because if they know where they are losing time, they can go back and scale the number of servers on the pool, or they can actually optimize the code to fix something. If we are using the advanced services for the WAF, so the application firewall or other features that involve recognition of signatures, there is a ALB, the AV Pulse, which is a central repository that downloads for the controllers the signatures of attacks for example, identifying DDoSs or known signatures of attacks that try to poison your request and things like that. You have that facility if you are using the WAF configuration. So, from a software-defined platform, you have all this capability that allows you to create your infrastructure in a quick manner and a flexible manner. So it allows you to stop worrying about going to the UI, set up something. You can automate these from Ansible, curl, whatever is your tool of choice, you can do this. It's pretty easy to do a simple deployment of automating from scratch, deploying the service, deploying the controllers, setting up everything, starting deploying services on it. From the application services point of view, you have the local traffic management, so you can manage the load balancing traffic and you can act on that. You have the global traffic management, so you have a GSLB capacity on the product. You have the app security in the WAF, so you can do some security as simple as deny queries or deny requests from a certain IPs to I want to make sure that if it is a request for this URL, it does not go through. So you can actually move and change what is happening on the request. And then you have the containers ingress service, which is instead of using one of the challenges that a lot of the big customers that use F5 have with the containers platforms is every time they need to deploy a service, they need to deploy the service on the Kubernetes and then go to the F5 and configure everything manually, while the way that AV interacts with the Kubernetes or with the TKG, it does not matter because it works for both. They have an operator that does that for you. You just need to make sure that that operator has the capacity to change the controller and have access to that to create a service for you. And then to join all this together, all this information is being processed by the controller and allows you to see everything that you need to analyze your services. Could be from security warnings and see, for example, what sort of ciphers you are using on our requests, if it is the right ciphers, what sort of certificates you are using, how much of those are using TLS, how much of them are using different versions of TLS. And then you can almost troubleshoot everything from the solution itself. The behavioral ML engine or the machine learning engine is really, it works really well with, for example, the app security and WAF because you can create your own expected behaviors to create your own signatures based on the default signatures that comes from outside. Okay, so the control plane has typically two ways of being built. You either do a standalone as NSX, same thing, or you do a 3-node cluster. And the principle is always the same. You lose one, you have like that mill that kind of works more or less, but you still have in the fall. If you lose two, you cannot do anything. It's pretty much gets in a read-only state. It keeps the things running, but it does not allow you to configure extra stuff. Typically for production, you want a 3-node cluster. However, a standalone solution is not completely out of the options if you can guarantee that if something dies in one side, you have a recovery process that allows you to recover. Data plane is, you have the service engines, that is where the work is done, to be fair. So what happens is you configure stuff in the controllers, the controllers push the configuration for the service engines. And then you have your VMs that run your applications that are grouped in pools. So, as we were talking about, there is basically is a product that is always cloud-based. It is not only for the data for your data center. It can actually, if you have a set of controllers, you can control the multiple clouds with the same controller. One thing that is good is because the type of configuration is quite similar, it's pretty easy to pick up a configuration that is on premises and then suddenly you set up the same setup somewhere on the Google Cloud or on the AWS. These on the types of cloud, so the cloud is a configuration constructed now. So you have two main points, which is the right access cloud, which is, for example, on the vCenter clouds and NSX clouds, you have a capacity of writing through the orchestrator and creating load balancers. And there you have the no access cloud, which is you deploy the machines, whatever you want, and then you connect them back, and then you build that structure by yourself, which means that these machines can be running whatever you want. And when I say whatever you want, it does not even need to be running on the same platform. If you're running a service engine, then it can be, for example, in theory, you can have one running in AWS, one running in VMware Cloud. It does not care. If your controller is going to see, I have to load balancers, I can provide services on it. There's three big availability, there's 2/3 availability modes. So the availability mode is, you have the legacy one, which is the traditional one, active standby. It's called legacy because it's pretty much what AVI is not all about. It's pretty much, if you are doing that, it's because you have like, either you have a use case that you really need to do that, or you want to keep the things as they were before. So you have the challenge that you have one active, one standby. You cannot scale horizontally, so you only are stuck with 2 service engines. If you want more performance, you need to increase the number of CPUs or the size of the VMs, etc. But you cannot scale horizontally. And failovers require always the management plane to be alive. So this is something that's going to change, but for now, that is what is happening. Then you have the two active modes. The main difference between the two active modes is how they are set up by default. But in the end, they work in a similar way. And the idea is, if you have a set of service engines, your virtual service, so your VIP, can be serviced by any of them. So what happens is, let's say that you have 4 service engines, for example. You can have one service that is scaled over the 4, which means that when you do the request, your service, instead of having one single machine capable of processing your request, you have 4 machines processing your request. And that is all done transparently for the final customer. And and that is what is the 3 big modes of the HI is. In this case, it's traditional one files, the other one picks up. In the active modes is you can have multiple failures because you have multiple service engines there, and your damage every time something fails is minimized. If you have 4 and you lose 1/4 of the resources. You don't lose 100%. So it means that out of your 100% of the services that were running or 100% of the requests, you're going to lose only the requests that are being hosted on that service engine itself. Okay, so the database scaling is literally one of the main differences. On the traditional service engines or on the traditional load balancing, when you have 2 CPUs and you need more power, when you have that standby model like F5s or anything else that only do that, you need to have more CPUs, you need to have more memory. So if you in the F5 world, if you need to have more performance out of a chassis, you need to buy a bigger chassis, you need to invest in hardware. In AVI, you have the capacity of doing the scale horizontally by leveraging the elastic HI. So in this case, for example, if you have 2 CPUs and you think, oh, I need more. Instead of growing the service engine, you can create one aside, and now you have double the capacity, double the bandwidth, and that allow you to also increase your resilience for the service. And then if you need more, you can grow more. So this is limited by the type of cloud, the type of native scaling that you are, the type of scaling of the type of service engine group and the type of scaling that you are using. So this is the data plane scaling. So this is how you grow the capacity of your service engine group. The service engine group is a construct that is how you group up multiple service engines to provide kind of a load balancing entity, right? Then on top of that, you can also grow or scale the virtual service itself. So you have 2 ways of doing that. You can do the native scaling, which is so in this example you have 3 VMs, that is your pool members. Then you have one single service engine. So let's start simple. You have your client that makes a request to your service engine. Your service engine have the capacity, you're going to respond, and you go back. So suddenly you have an increase of requests. You have 2 options. You either struggle with the one that you have, or if you have the capacity to scale natively, you will increase the number of service engines on the group. So you will deploy new service engines if you are in the right mode, and you will allow you to divide the work across them. And the native scaling works in a way as you have one service engine that replies to the ARPs for the VIP address, and then if he cannot process the request, he's going to pass the work to the other service engines to basically go back to the backend service to make the requests. And then on the way back, the service engine masquerades the response to make sure that the client isn't aware that it came from another service engine, but it means that at this point you have the 3 service engines replying back, and for you it's transparent. The native scaling has a limitation, which is 4, and also means that this first primary service engine is not only doing the work of processing your requests, it's also doing these kind of shifting the work. So it could mean that in an active, busy, really busy environment, this service engine could be only doing 25% load balancing and 75% doing dispatching. So that is the downside of doing these. But it does mean that instead of one processing unit, you have more than one processing unit. So overall, you are splitting up the work. Then you have the ECMP scaling that it can be achieved by multiple ways. Either by, for example, setting up BGP between the service engine and the router in front, or in case of the NSX Cloud, the automation and the integration will add static routes to the T1s that you connect your service engine, and will create the ECMP routes on the T1 to allow the traffic to be distributed directly to the service engine. So what it means is you have the same situation, but now you have a router in the middle. So when your request comes in and it's a single service engine, you only have one route, which means that there is a route that says that my VIP address is behind the service engine IP. So you have a /32 on the T1. The work is okay, goes back. If you need more, what happens is the service engine group scale creates more service engines, and then the controller injects routes on the T1s that say, okay, my VIP address is not only behind this one, is behind also the service engine 2, the service engine 3. So it means that at this level, you have an ESMP distribution of the traffic across the 3 service engines, and they are working separate. So they are separate units at this point. So the problem that you have here, where you had a pain process of dispatching the work, in here, that does not happen. So it means that your service engine are working as individual units. There is an exception, and for example, if you lose one service engine, there is a period where this methodology comes into place to help out reposition these connections to these service engines. So it does mean that it tries to recover the lost service engine and tries to redistribute the work across these ones. So it means that this works for the new connections, and once the hashing is properly stable, you end up doing that redistribution. This is a detail that sometimes we forget when we are in, for example, setting up the DFWs on this case. So if we set up a DFW on this case, you're going to be filtering those traffics on that instance moments. In here, the solution is actually excluding the service engines from the DFW. Okay, so I'm on time. Good. So, key use cases. So the 3 main use cases is data center automation. So when you have, one of the challenges that we have with a lot of customers is, I have a load balancing solution, but it takes too much to get them to the market. As in, deploying a service could take ages. I am working with a customer that one of their complaints and one of the things that why they are moving to Avi is, it takes, with all the authorizations, with all the approvals, etc., it takes almost like a month to get the service implemented on AF5. What they are trying to do is, if they automate the process, and if they automate all the authorizations, it can be a simple process of taking 1 day, for example, to get all the things aligned. All the solutions, all the out-of-the-box ecosystem that you can have, it allows you to automate all of these in a simple manner with some effort from the development side, but it's something that is nothing new for anyone. I actually think that if you have any knowledge of an API, or if you automated anything, for example, with NSX, I would say that doing this for Avi is way simple because it was created from scratch with that purpose. And all the things I expose, all the things I see to do. The other bit is a multi-cloud consistency. So when you have multiple solutions of load balancing, you never have the same experience. As in, creating a service on AWS for load balancing is not the same thing, for example, creating a service on F5 in a local data center. by having a product that can span across all of them allows you to have that experience exactly the same. So creating a service on, for example, on AWS or in the VMware cloud within your data center, while some of the details are different, the structure and the way they approach the solution is all the same. And that is an important part for some of the teams that have some gaps on the knowledge or it takes time to train. With this, it's a simple approach. It's like everything is the same. And then the part of the visibility and troubleshooting is where is really, really interesting for the application owners. Checking how much of your service is actually performing. How much do you need? Are you running it completely on the red line or you have spare capacity? One thing that is, for example, because you can scale individual services, you can, for example, have a mix and match within the same set of service engine. You can say, okay, this VS, for example, this V is a gold tier. I want it to survive all the failures in the world and have all the capacity in the world. You say, okay, this service runs in 4 service engine. Then you have one that is for dev. I don't need resilience, I don't need anything. I can run in only a single service engine. So you can mix and match the size of your service or your VSs based on what your final customer needs. Same thing with the GSLB. You can, for example, decide, okay, this service needs GSLB. I'm going to go for this service with GSLB. The other ones don't need to be. The way it works is kind of really easy to go through all the different solutions without having to relearn a lot of the things, because it's just rinse and repeat once you understand how it works. What time is it? Okay, so I'm just going to go through these ones. So this was one customer that had like a massive F5 infrastructure, and one challenge that they have is it was taking too long for them to do anything when they need to change. They, for example, they are business that need to move the resources from one week to the other based on what is happening in the world. And what they did is they look at RVS the approach of, we want this automated. We want something that you can say, I want to move the resources from here to here, and I don't need to spend 2 hours reconfiguring the F5s or leaving objects there disabled, etc. So what we did in them is like, so they had these divided in multiple stages, and at this point they were like big F5 chassis, and they have virtual chassis, and they had multiple areas where they were dealing with the solution. They had like one for the external, then two for the webs, then have one internal for the internal services, and then they had applications that were also load balancing. Some of them were Kubernetes, some of them were native applications or normal applications. What we did is, the way that we did, we optimized some of these areas, and we consolidate some of the service engines, and we created a structure where they had a set of service engines that were shared across the multiple tenants and the multiple areas, and then they were shifting the resources and deploying service engines, killing service engines, and moving them around. So the way that they were seeing things is like, for example, they needed more capacity on this side of the things. They were saying, okay, we're going to reduce the size of these, move some of the licenses for there for 2 days or 3 days, and then we're going to move back once we need again. And on top of that, we gave access to their final application owners to get statistics and see the analytics of their own application. So they would log in on the UI and would see exactly only their services. They were not having access for doing anything besides looking at their services. And that was based on, it was funny because when we start planning these all authentication issue, we were coming up with almost 400 different roles for trying to make sure that they have only access to things. And what we did is we reduced that to 18 roles, and then those 18 roles, which were kind of changing based on the name of the group of the Active Directory that they were belonging to. So This was deployed across 3 data centers. This was a thing that was created through the read-only cloud. So they were deploying the service engines and they were killing the service engines all based in Ansibles. So everything was coded in Ansible. They were putting the configuration on the GitHub and they were versioning it. It was the all automated process, all built in-house for them. They were really keen to share these because they loved the entire solution. They had 950 virtual services migrated in one of the environments. Then one of the challenges for anyone that works in F5, the I rules are a nightmare because some of them are written ages ago. No one knows why they were written. And then a lot of them are not even sure if they really do anything. One of the things that we spend is like, we reduced the number of I rules that I had to a point that some of the I rules were in F5 were a bunch of code doing stuff. In Avi was going through checkboxes and drop downs and selecting things to make sure that it worked and do exactly the same. So on this case, they decided we don't want to do what we have in F5. We want to do what we are trying to achieve. We don't care how we done in F5. So we had the chance of restructure a lot of the F5 traditional I rules to something that would work how the product should work and not how we work with F5. So this was a no orchestration cloud. So spin up service engines, spin up controllers, spin up services, spin up everything was done through automation created by the customer. So it was nothing to, the only thing that VMware had in terms of automation on this case was the updates and the upgrades. And even that was triggered by Ansible. So they were actually asking the controllers to upgrade the things through code instead of them going to the UI and do stuff. This was all done with BGP. So between the service engine, so between the load balancer and the routers in front, they were running BGP to propagate and do that ECMP traffic and input and add the rules and remove the rules from the BGP tables. The service engines, so before we had, for example, a high load capacity for a specific area. In the way that we did, we consolidate these in big sets of service engine groups that they would basically share across multiple tenants, because within the tenants, we were separating them in VRFs. So in Avi, you have the VRF construct, which means that you have a separate networking stack within the service engine that is fully contained in that separate VRF. So they were sharing the hardware resources on the VMs, but they were not sharing the networking itself. And automated Ansible, the SE lifecycle, the virtual services lifecycle, the scaling of the service engine. So growing the service engine, reducing the service engine, reducing whatever. They were doing everything through code. And they were checking one of the requirements from the customer was, we want real-time metrics. And they started by saying, we need 5 seconds real-time metrics. We gone to engineering and they said they are nuts. And when they say they are nuts, they said, I don't think that we can process the data at that speed to make sure that it can get metrics out of every 5 seconds. Because one of the challenges is not giving the metrics every 5 seconds, is getting the metrics from the service engines, processing them and making them available in 5 seconds. So we needed to get engineering to develop some extra capacity and analyze how much they could optimize this thing to be able to do real-time metrics. They were doing these through Prometheus calls, so they were using Prometheus to monitor all of these. And the granular ROI, which is for each object, we were limiting what the user could see. And yeah, so it was a mix of traditional workloads, Kubernetes. So in all of it, they end up replacing all the F5s by Avi. They started on the journey where we're going to see how it goes, and then suddenly they start replacing everything because they were looking. There was a bit of solution was still running on other sets of load balancers that had a specific functionality, but they were having a phase 2 after the success of the phase 1, where they wanted to also replace those ones because they saw the benefit of the API and everything that they could outside. And I think it's all. Thank you very much. I know that it's pretty much better than I. My contact if you need any help or if you want to reach out, just feel free. I don't have any problems. I work for VMware, so I'm always available for you guys. So.